Hello everyone, welcome to Grade Up. How are you all? How are you all? Fine? Good evening. So today we are here to discuss important questions from measurements. Okay? Important questions from measurements, and all the important domains are covered in these type of questions which I will discuss today. Okay? Are you all ready for the session? Everyone ready for the session? Yes? Should we move? Okay, let's begin the session. So, in measurements, error is an important topic, and PMMC type meter is an important topic that you have to cover, and CRO Lissajous patterns. Okay, so we will be dealing with those type of questions in this class. Let's begin with the first question. As the deflection of moving system increases, there is a deflection type of instrument, okay, in which the moving system deflection is increased. Then what happens to the controlling torque? What happens to the controlling torque? My dear friends, the deflecting torque is equal to the controlling torque, then only the pointer will come to steady state. Means controlling torque should be equal to the deflection torque, then only on indicating type of instrument the pointer is going to be balanced. Yes. So at that position where the deflecting torque is increasing, so to find the balance position, you need to increase the, means controlling torque also increases in proportion. Yes, controlling torque should also increase the proportion for the pointer to be in the steady state. So controlling torque also increases as the deflecting torque increases to make the pointer stable at a particular value. Okay, did you get this? Did you get this? Come on, post your answers. Post your answers. So option will be B. Yes. Next question. Which is the best type of emitter moment? Which is best type of emitter moment? So the best type of emitter moment will be D'Arsonval's galvanometer. Best type of emitter moment will be D'Arsonval's galvanometer. Okay, because the scales are linear. For DC measurement, best is PMMC type meter or D'Arsonval's meter. Okay, so the best option available is C, D'Arsonval's meter. Why are you not responding? Why are you all not responding? Are these difficult questions? Are these difficult questions? अमित ध्यान कहाँ है? Yes. Yes. So reply as soon as I give the question. Next question. Which dynamometer has a uniform scale? I told you earlier that the devices or the instruments which will point the average value will have linear or uniform scale. You can say it will have uniform scale. Better word is uniform scale. all the values are placed uniformly. Okay, all the values are placed uniformly. Whereas in case of non-uniform or cramped scale, the initial values will be very close and rest values will be far off. Okay, so wattmeter is a type of dynamometer. Wattmeter is a type of dynamometer. Wattmeter is a type of dynamometer and it measures average power. So the correct option will be A. Dynamometer type of wattmeter measures average power. So it will be wattmeter. Okay. Animesh, correct answer. Let's go to next question. When both the deflecting torque and controlling torque act, the pointer of an instrument comes to. My dear friends, in the first question I discussed, controlling torque equals to the deflecting torque. Then the pointer should come to, yes, what should be the position of pointer? Pointer of position should be at rest. PMMC type meter has uniform scale. PMMC type meter has uniform scale, but it is not a dynamometer. Okay. Animesh, correct answer was wattmeter, but the reason which you listed was wrong. PMMC type permanent magnet moving coil instruments have uniform scale, but they are not the dynamometers. Yes, this type of classes will be held for each and every subject. Okay, don't worry. This type of class will be held for each and every subject. Let's move. The output voltage of a thermocouple. There is a thermocouple. The basic example of thermocouple is iron copper thermocouple. Iron copper thermocouple. One junction is at high temperature, one junction is at low temperature, and the EMF induced is S into del T. EMF induced is S into del T, where S is the sensitivity of the thermocouple and del T is the temperature difference. So the EMF induced increases with the temperature. C option. C option. T2 minus T1. As you increase the temperature, the EMF induced increases. Okay. Yes. Next question. An instrument in which the magnitude of measured quantity is indicated by the means of pointer is analog instruments. Analog instruments. Okay. My dear friends, if you go for ammeter and voltmeter, if it is confusing to you, ammeter and voltmeter can be digital type also. It is not defined whether it is a digital ammeter or a digital voltmeter or deflecting type ammeters and voltmeters. So the best option will be A, that is analog instruments. Okay. Next question. If the pointer of an indicating instrument is in motion, if the pointer of an indicating instrument is in motion, means the pointer is moving, then what opposes the deflecting torque? What opposes the deflecting torque? Tell me. C option. Both the damping and the controlling torques are opposing the deflection. Yes, both are opposing the deflection. Controlling torque will oppose the deflection for this value TD equals to TC to make the pointer come to steady state position. Okay, but the damping torque will oppose the pointer so that pointer does not oscillate. It means both the torques, damping torque as well as controlling torque, will oppose the pointer movement. Correct? Praveen, your answer is wrong. Animesh, wrong answer. Yes. How can electric currents be reduced with a coil and a magnet? How can electric current be introduced or induced in a coil and a magnet? As per Faraday's rule, as per Faraday's rule, when a coil or a conductor is moved, okay, it is not stationary, it is moving in the magnetic field, then EMF is induced in it. So by moving either the coil or the magnet, okay, by either moving the coil or a magnet, those of you who are saying by placing there will be no effect. In fact, EMF is induced when there is a relative motion between coil and the field. Okay, when there is a motion between coil and the field. Okay, Chintu, you are saying itna easy आएंगे क्या? Have you replied anyone? Have you replied? I haven't seen your reply. एक भी क्वेश्चन रिप्लाई नहीं किया. It seems easy to you. Yes. See, by placing, keeping stationary the magnetic field and the coil, you cannot get the EMF induced. Only when there is a relative motion, then only EMF will be introduced. Okay. Yes, I think that Chintu will leave the session now. Let's move to the next question. The Wheatstone bridge is balanced if. What is the condition for a Wheatstone bridge to be balanced? What is the condition for the Wheatstone bridge to be balanced? This is the Wheatstone bridge. I earlier also told in the session. These are the impedances. It is the detector position. It is the position of the source. For the Wheatstone bridge to be balanced, Z1 by Z3 equals to Z2 by, sorry, it will be Z4. Z4. Okay. Product of opposite arm impedances should be same. Z2, Z3. Okay. So C option is the correct option. Okay. See, Chintu did not reply and the question seemed to be easy to him. Okay. Next question. The pointer of an indicating instrument is in the final deflection position. Okay. The pointer of an indicating instrument is in the final deflected position. Dash is 0. Which torque will be 0? Okay. Which torque is 0 when the pointer is in steady state position? Damping torque is 0. Now many of you will have confusion about the damping torque. Yes. If deflecting torque will become 0, my dear friends, if deflecting torque will become 0, suppose it is a meter. Suppose it is a meter. If deflecting torque will become 0, then pointer will go back to the 0 position again. Okay. So deflecting torque cannot be 0. Controlling torque cannot be 0 at this position. If controlling torque is 0, the pointer will go to show full deflection. Okay. Damping torque is 0. Okay, damping torque is 0 because the oscillations are stopped, and also frictional torque will be 0 because the pointer is not moving now. The pointer is at a stable position, so there is no friction in movement of the coil or movement of the pointer. Yes, the arrangement is such that it is a spindle, it is a jeweled bearing, okay, and on this pointer is mounted, okay. So once the pointer is showing the final position, the friction here will also be 0. Yes, so frictional torque is also 0 and damping torque is also 0. Okay, both options will be correct. Okay, both options will be correct. Okay, next question. Yeah, Anudeep, see, question of your favorite topic, energy meters there. Disk is made up of which type of disk is made up of what material in eddy current damping? With respect to the energy meters, in the previous question, option C and D both are correct. You can challenge for both. Okay. In this question, the disk is made up of conducting. In the energy meter, disk is made up of aluminium, that is a conductor. Okay, but it is actually non-magnetic material also. The material is non-magnetic, so A option will be correct. Okay, conductor and a non-magnetic material. Okay, it is a conductor as well as a non-magnetic material. So 87 people are live, but without means likes. Chintu, you are back. A correct option. So 87 people are live, and I am having just 8 likes in this live session. How is it possible? Next, an oscilloscope provides an easy measurement of easy measurement of peak to peak values. Yes, in oscilloscope you can easily calculate peak to peak values. Okay, correct. Peak to peak values. Correct option. Hot wire instrument measures RMS value. Hot wire instrument measures RMS value because RMS value is calculated from heating effect of current. RMS value is calculated from heating effect of current. Hot wire instrument measures RMS value. RMS value is calculated from heating effects of current, and heating effects of जो भी meter, any meter which points to the RMS value will have squared scale. B option is correct. Next question. Fluid friction damping is employed in one of the following. In which of the following fluid friction damping is employed? Fluid friction damping is employed in those instruments where sensitivity is least important. जहां पर sensitivity least important हो. So the correct option in this will be electrostatic voltmeter type. D option is the correct one. Yes, D option is correct. Electrostatic voltmeter type. Okay. Electrostatic voltmeters can measure high voltages up like thousand of volts. These are measuring high voltages like 1000 volts. Okay. Permanent magnet moving coil can be used in. Yes, my dear friends, permanent magnet moving coil instruments are used in measurement of PMMC meter measures only DC value. PMMC meter measures only DC value because due to that horseshoe magnet which is used in PMMC type meter, the direction of magnetic flux is same. It cannot be reversed to measure AC value. Okay, so PMMC type of meter is used for DC work only. Okay, so the correct option will be option C. Okay, correct option will be option C. Next, what CRT element, which CRT element provides control for the electrons passing the farther into the tube? There is a screen for the electrons passing farther in the tube like this situations. Okay, which type of element should be required? Tell me. B option, control grid. Correct. Control grid is used to guide all these electrons to a proper place. Likewise, some of like students are roaming here and there. There should be some control grid so that they can be focused. Yes, so that they can be focused to crack RRB JE. This is what we are doing in this live session. Okay, so CRT has control grid to guide the electrons. Okay, yes. Which moment is which moment is most expensive? Which moment is the most expensive? Secondary emissions are reduced by giving some positive potential at the electrode so that it can be collected easily. Electrons can be collected easily. Most expensive कौन सा है? Have you ever gone to the market to purchase? A option, DRS walls. ये तो बहुत easy है. So dynamometer is actually consisting of two coils. Okay, dynamometer consists of two coils and it is expensive. Okay, this question is least important. This question is least important. Two coils of pure copper are required. It makes this instrument more expensive. Did you get it? Did you get this thing? So it is easy. Okay. Attraction and repulsion instruments are considered as. Tell me. Attraction and repulsion instruments are considered as. In moving iron instrument, there are two types: attraction type, moving iron instrument, and repulsion type. Okay, so B option is correct. Moving iron has two categories as attraction and repulsion type. Okay, a small swamping resistance is connected in series with the operating coil of moving coil emitter. A small swamping resistance is connected in order to compensate for the effects of. Yes, to extend the range of emitter, we have placed a resistance in parallel, shunt resistance in parallel. This shunt resistance is made up of manganese, and also to avoid this temperature variation Another resistance is placed in series with the meter having value 40 times of Rm, 40 times the meter resistance, okay, to compensate for the temperature variations. Okay, manganese. Okay, the temperature coefficient of resistance of the shunt material is, what is the temperature coefficient of resistance for the shunt material? R equals to RT naught 1 plus alpha del T. So the temperature variation should be least. Temperature variation, temperature coefficient should not be negative, otherwise temperature बढ़ाओगे resistance negative में आ जाएगा. It should be negligible. It should be negligible. With the rise of temperature, the resistance change should be negligible. Okay, very good, correct option. Next, in an oscilloscope, dash adjusts the brightness of the spot. Tell me, brightness of the spot is adjusted by intensity control. Correct, intensity control. Okay, intensity control. Brightness of the spot will be controlled by intensity control. Whether you want a bright spot or you want a dull spot, that will be governed by intensity. Okay, yes. Next thing, a dash operates on the magnetic attraction repulsion principles. Yes, magnetic attraction repulsion principles. So spectrum analyzer finds out the number of frequencies in the particular signal. Oscilloscope uses electrostatic deflection. Field strength meter is having different phenomena. Milliammeter measures value from magnetic effects of electric current. Magnetic effects of electric current. Okay, it measures from magnetic. Dynamometer type instrument can be used for, dynamometer type of instruments are used for AC, DC, both AC and DC. Tell me. रोशन पांडे भाई, अब बता. रोशन पांडे, अब बता. Please maintain the courtesy of the class. You are replying like that, huh? Comments are. It is used for both DC as well as AC. Dynamometer type of instruments are used for both DC as well as AC. Okay. Next, dash is an instrument in which spring provides the control as well as serve to lead current, means current is passed on to the coil by using spring control. Which type of instrument is it? Which type of instrument it is? It is PMMC type instrument. Correct. In PMMC type instrument, the spring is made up of phosphor bronze and it is responsible for two things: to provide the controlling torque as well as to provide the currents. Okay. An instrument which is used for observing voltage and current waveform is the, which instrument is used for observing voltage and current waveforms? Yes, which instrument is used for observing voltage and current waveforms? Oscilloscope. It is used for observing the voltage and current waveforms. Examples of null deflection type. Example of null deflection type will be your galvanometer, tangent galvanometer. Okay, and deflection type of instrument is your PMMC type meter, or you can say PMC type meter as well as ammeters, voltmeters, all those things. Null deflection type potentiometer, correct? Potentiometer, bridges are null deflection types. Okay. So an instrument which is used for observing voltage and current waveforms is oscilloscope. Next, which type, which of the following extends the range of moving iron AC emitter? How to extend the range of moving iron AC emitter? By connecting shunt. Yes. Then you have a shunt. Okay. In this shunt resistance and inductance is there. In in the shunt of moving iron AC emitter, resistance and inductance are there. Okay. Shunt in parallel. This inductor is because of inductive nature of the coil, and resistor is because to provide the low impedance path. Okay, it should have less value than the meter resistance. Okay, this option, by changing the number of turns of the operating coil, once the instrument has been designed, you cannot open the coil and coil it again. Okay, you cannot open the coil and coil it again. एक बार आपने इंस्ट्रूमेंट बना लिया वोल्ट मीटर, नाउ यू वांट टू एक्सटेंड द रेंज, आप उसको खोलेंगे और फिर से कॉइलिंग करेंगे? नो. सीरीज में to extend the range you have to provide a bypass path for the excess current. That is why shunt में add करते हैं resistor so that extra current passes through this path. Okay, yes. Now in voltmeter, to extend the range, it is added in series. Okay, in voltmeter, to extend the range, resistance is added in series. When the current through the operating coil of a moving iron instrument is tripled, the current value initially was I, but now the current value has been increased to 3I. What is the deflecting torque? Deflecting torque is proportional to I squared dl by d theta in case of moving iron instrument. So if you have increased the current by thrice, deflecting torque will increase by a factor of 9 times of original, because deflecting torque is directly proportional to I square. Deflecting torque is directly proportional to I square. So 9 times. Are you all enjoying the session? Are you all enjoying the session? Yes. Next question. The element of a CRT that releases electrons when heated indirectly by a filament. When heated indirectly by the filament. Yes, what is that element? A CRO is there. Here you have cathode. Cathode is used for emission of electrons. Okay, and here you have pre-accelerating anode, focusing anode, then you have accelerating anode. Okay, cathode, this is the arrangement. Cathode is responsible for emission of electrons. Anode is responsible for focusing the electrons. Okay, anode is responsible for focusing the electrons, and here you have horizontal and vertical deflection plates mechanism, and here is your screen. The screen is coated with phosphorus. So electron emission is from cathode. Amit Tiwari, correct answer. Anurag, correct answer. Amit, how the option is B. Amit Singh, how the option is B. Wrong answer. Is it clear? CRO is clear now. CRO is clear. The pulse generated, the signal generated inside the CRO is sawtooth waveform. Sawtooth waveform. This sawtooth waveform is generated by UJT. This sawtooth uniform is generated by UJT. Okay, remember this thing. Remember, cathode is used for emission of electrons, anode is used for guiding the emission of the electrons. Okay, next. A pattern display by oscilloscope which has a steady characteristic is called. A pattern display by the oscilloscopes, okay, which has a steady characteristic is called Lissajous pattern. Lissajous patterns. These Lissajous patterns are important for calculation of frequency as well as phase. These Lissajous patterns are important for calculation of frequency as well as phase. Next, which of the following is not a basic part of CRT? CRT is cathode ray tube. Which of the following is not the basic part of CRT? Tell me. Question number 30. Yes. D option. D option. It is outside that CRT, cathode ray tube. Okay. Rest everything is inside CRT. As I discussed in the previous, cathode, anode, and everything is inside the CRT. Sawtooth generator is at the outside of cathode ray tube. Okay. Let's move. A PMC meter. Let's begin with the numericals. Yes. Let's begin with the numericals. A PMC meter has an internal resistance of 1 ohms and a full scale deflection of 100 milliamperes. Let us see. What is this? Meter resistance Rm is 1 ohms and current Im for full scale deflection is 100 milliamps. To extend the range to 1 ampere, a shunt resistance is connected across it in parallel. Current passing will be I shunt and this current to be measured is 1 ampere. Okay, this current to be measured is 1 ampere. Can you say that R shunt equals to Rm upon M minus 1, where M is the multiplication factor? What is this value of M? This value of M is I, the net current, the extended range upon the meter value. Meter value is given as 100 milliamps. It will be 1000 and this multiplication factor will become 10. This multiplication factor will become 10. So you get R shunt equals to Rm, that is 1 ohms divided by 10 minus 1, 1 by 9. This will be A option. A option. My dear friends, the shunt resistance should be less than the meter resistance because it has to bypass the current. It has to bypass the excess current. So it should be less than this meter current. Otherwise, the shunt current should be greater than the meter current and shunt resistance should be less than the meter resistance. Otherwise, it will blow off. Okay. Suppose two resistances are there and you have to pass more current through this resistance. Then what should be the value of this resistance? It should be low. If you have to pass more current through this resistance, then this value of resistance should be low and it should be maintained at some particular value. Okay. Yes. Next question. A voltmeter having a meter resistance of 100 ohms and a full scale current of 2 milliamperes. See, it is a voltmeter. It is having a meter resistance of, meter is 2 milliampere Im, meter current. Okay. And it has a range of 1 volt earlier. But now you have to extend its range to, it is 1 volt. You have to extend its range to 5 volts. Then what will be the series resistance? To extend the range of voltmeter, you need a series resistance. How are you going to calculate series resistance? Yes. To find it very easily, you find the meter resistance first. Meter resistance is voltage upon the rated current. What is this value? It will be 2 milliamperes. It is 500 ohms. It is 500. What is Rm? What is the meter resistance you are getting? 1 volt divided by 2 milliamperes. Or in fact, you can do one thing more. Rm into m minus 1. Okay. Okay, leave this part if you are not getting Rm. What is the total resistance as seen? 5 milliampere and 2 milliampere current is flowing through it. 5 milliampere is the net voltage across it and 2 milliampere current is flowing through it. So total resistance as seen from this terminal will be 5 divided by 2 milliamps. It will be, yes, answer. No one will give the answer. 2,500. It will be 2,500. Yes. Are you getting it? Total resistance is 2,500. Rm meter resistance will be drop across meter upon the meter current 2 milliampere. It will be 500 ohms. So what is the value of resistance to be added? What is the value of resistance to be added? The value of resistance Rs will be total resistance minus meter resistance. So it will be 2 kilo ohms. So get the result like that. Okay. M equals to 5 by 1, correct? Rm you know by voltage upon current. Okay. Rm you know as 500 ohms. Can you easily apply the trick that R series will be Rm into M minus 1, where M is capital V by small v, where capital V is the total voltage to be measured, the extended range, and the small v is the voltage across the meter. Yes. Yes. So better go by that. Okay. So better go by that. Okay, meter resistance is given as 100. You are saying that meter resistance is given as 100. Okay. In this question, meter resistance was given to you as 100. It is actually saying of the thing, clear my doubt. Okay. Take it. There is a series resistance. There is a meter resistance Rm. which is given to you as 100 ohms. Okay, a voltmeter having meter resistance of 100 ohms. Okay, meter resistance is known to you as 100 ohms. But actually, when we go through this formula, scale is this. Actually, in this question, there is an ambiguity that this meter resistance should not be given. This meter resistance should not be given. Okay, it is a fault from the technical that content team. Meter resistance should not be given to you. Okay, yes, Amit. Now you clear your doubt. Now the doubts are cleared. That meter resistance should not be given to you. You have to calculate the meter resistance from this value and proceed. Then you will get this result. Okay. That meter resistance is creating an ambiguity in the question, and the question will be wrong then. Okay. Is it clear now? Is it clear now? Okay. Okay. That was the means. Okay, it was wrong from the content team. Okay, it was wrong from the content team. Yes, that meter resistance should not be given to you. Okay, and if you don't consider it, then actually the current is given to you now. If actually the range should not be given, then either range should be not given, or the current should, and or the meter resistance should not be given. Okay, if we consider this value, why to consider that value, Amit? Why to consider this value? Either you take 100 ohm meter resistance and neglect this value. Okay, and neglect this value. Then you find out the new value of V and multiplication factor. Okay, and you find the new value of V and the multiplication factor. So the better a voltmeter has full scale deflection, this line should be eliminated and you will get the answer correct. Okay, next. Three impedances of an AC bridge is shown. Three impedances of an AC bridge is shown. Z1, Z2, Z3. How to find Z4? I told you for the bridge to be balanced, Z1, Z4 equals to Z2, Z3. To find out Z4, it should be Z3, Z2 by Z1. Okay. What is Z3? 5 at an angle of 45 degree multiplied by 20 at an angle of 45 degree divided by Z1 100 at an angle of 0 degree. Yes, 1 at an angle of 90 degree, 1 at an angle of 90 degree. Correct. Correct. The current and the voltage across the load are shown to be, you know the current, okay, you know the voltage. What is the relative error in the calculation of power? You are calculating power. What should be the relative error? Yes, del P by P into 100 equals to power equals to V into I. For multiplication case, the relative errors will be added. It should be del V by V, del V by V into 100 plus del I by I into 100. It is 0.1%. It is 0.5%. It will be 0.6%. The relative error in calculation of power. Okay. Actually, this sign you replace with this sign. Del. Okay. If voltage and resistance are given, how to find error? Okay. Take the case. Take the case. Voltage is given to you as 1 plus minus 0.1% of V, and resistance is given to you as, take 5 plus minus 0.5% of ohms. Okay, power equals to v square by r. It will be twice del v by v plus del r by r, and this will be del p by p. Amit, did you get this? Amit, did you get this now? Yes. So twice of del v will be 0.1% plus del r will be 0.5, 0.7%. Okay. Plus or minus is not your concern. It should be plus minus. It should be plus minus. Okay. Even if it is in division, you have to take it as plus because it is talking about the maximum deviation. Okay. Because it is talking about the maximum deviation. It should be plus minus 0.7%. Those of you who are having doubt that v square by r here negative should come is wrong. You have to take the maximum condition and it should be plus. रूपकरण में वही समझा रहा हूं that in this position you have to take plus because you are talking of the maximum deviation. Okay. Next, two resistance with the values R1 and R2 are given to you. Find the resultant resistance. It is a case of series calculation. So in the case of series calculation, the net resistance R equals to R1 plus R2. What is the value of R1? 200 ohms plus 100 ohms equal to 300 ohms. But how to calculate del R? That is the deviation or the limiting error of the series. It will be del R by R into 100 equals to R1 by R into del R1 by R1 into 100 plus R2 by R into del R2 by R2 into 100. Okay. What is R1, dear friends? 200. R is 300 multiplied by what is the deviation? 2% plus what is R2? What is R2? R2 is 100. 300 multiplied by 1%. So correct answer will be 4 by, it will be 5. Okay. 4 by 3 plus 1 by 3 equals to 5 by 3. Okay. 5 by 3%. So you will get 1.66% as the deviation. Limiting error. Limiting error. Relative limiting error is 1.66%. So option will be B. Option will be B. Now let's take the next question. The moving coil instrument has the following data number. Has the following data. Number of turns is given to you. N equals to 100. Area of the coil is given to you. 600 millimeter square means 10 raised to the power minus 6 meter square. Flux density Weber per meter square. Okay, it is 0.2 Tesla. Correct. If the current of 10 milliampere flows through the instrument, then find the deflection of the pointer. Spring constant K is given to you as 4 into 10 raised to the power minus 6. Okay. Then do you know this formula? Deflection torque equals to the controlling torque. Deflecting torque equals to N B A I. Yes. And controlling torque equals to K theta. Deflecting torque equals to N into B into A into I for the maximum case. NBAI. Bina. So calculate the values. N is 100. B is 0.2. Area is 600 into 10 raised to the power minus 6. I current is 10 milliamperes. K value you have been provided, and theta calculate from this place. You will get theta as 30 degrees. Okay, you will get theta as 30 degrees. Okay, so this was all to be discussed in today's topic. Okay, I completed the important things in today's session. What all was important from examination point of view and could occur in your examination in some or the other way. Okay, hope you all enjoyed the session. Hope you all enjoyed the session. Yes, how was it? How was the session? Was it fruitful to you all? Yes. So as few days are remaining, we will be starting these series to help you out to gain maximum in your examination. Okay. So stay tuned, focus, and you will surely be benefited from this type of series. Okay. We will be continuing this series for the entire subjects. Okay, don't worry. Okay, Virat Kohli, why to do research here? Okay, tomorrow most probably you will be having electronic devices and circuits, ADC. Okay, so thank you all for joining this session. If you have any queries, post your doubts in the comment section. Okay, download the GradeUp app. You have any queries, then you can directly solve means post your doubts there. And there are many students, those who are preparing for the same examination, and they will help you out. In fact, our community will also help you out in that. Okay, tomorrow's subjects. So transistor numericals are important. Basic type of numericals you prepare. Basic numericals you prepare, like calculating the means calculating IC, IB, that case that IB, IC equals to beta IB, such type of basic numericals you prepare. Okay, because you cannot say that it cannot be asked in the examination, as in the syllabus it is given BJT and FET. So try to at least try to know the condition of saturation, cutoff, and the active region. Okay, no measurement lectures are available on YouTube. Just do one thing, open grade up on YouTube and go to electrical lectures. Okay, in electrical it has been covered, and since cover the relevant topics that is important from means EC also, the topics which are overlapping, you can complete the electronic measurements from there. Okay, so it was all in today's session. Thank you for joining on Grade Up and hope to see you soon. Tomorrow, be prepared with the next subject. Thank you for joining us.